All right, so on your note sheet, you will notice it says we are doing operations with polynomials. So we're going to add, we're going to subtract, and we are going to be doing some multiplying today. This is going to be a no calc section. So we're going to write that down. I don't think you'll miss it after yesterday. Get a little break from it. And then we are going to talk about the different types of polynomials. So a monomial is going to be a polynomial with one term. Okay, a binomial, like a bicycle, is going to be two terms. And a trinomial is going to be, you guessed it, three terms. Okay, so we are going to be adding, subtracting, and multiplying today. We're also going to be familiar with this terminology here. Okay, so a polynomial is a monomial, which is one term, or it can be a sum of those. So a monomial could be like 1/5 x to the third. So things that are multiplied together, that is a monomial. Okay, for two terms, you are going to add two monomials together. So you could have something like 2x to the 5th minus 3x. And then I want you to come up with one for a trinomial. Okay, so a trinomial has to have three terms. You could use one of the trinomials that we've tried to factor. We could use a type like that. Doesn't have to be like that, but that is a quadratic trinomial. Okay, and then for example 1, you're going to recognize this is really similar to what we did the other day. So the first thing you're going to do is determine whether each expression is a polynomial. If it is, you are going to state the degree of the polynomial. So when you're deciding if it's a polynomial, do you guys remember a couple of those things we had to look out for yesterday? Yeah, negative and the exponent. Do you remember the other one? Yeah, we had the two different variables and the variable would be like underneath it, yeah. And then the other one was the square root. Now, yesterday, we had in the directions, it said it had to be a polynomial in one variable. Today's does not say one variable, so that is not going to be something we have to watch out for today. Okay, if it says one variable, you will still watch out for that. Okay, but for this one in particular, it can be okay if it has more than one. Okay, so for A, we have x squared plus x plus 2. So one of the things we have to watch out for are values underneath a square root. Okay, so this is going to be not a polynomial because you can't have variables under the radical. This does not simplify either. So even if you like had something that was added and if it was a perfect square, it still wouldn't simplify. You can't have the addition there. So this is not a polynomial because you can't have variables under the radical. Okay, that is a function, it's just not a polynomial function. All right, and then B, we're going to look at m to the 5th minus 3/4 m to the 7th. Notice that m to the 7th is on the side of the fraction. So if you were to multiply these together, m to the 7th would go on the top. Okay, anytime you have a whole number times a fraction, it goes to the top. So this is a polynomial. You don't have any fractional exponents. Okay, you don't have any of the roots with variables. Okay, so this is going to be yes. Yep, and then Nolan, what's the degree? 7. You know why? Yeah, largest exponent. Your degree is always your largest exponent. Okay, I do want you to understand that if you had m to the 5th minus 3 divided by 4m to the 7th, if that was in the denominator, that would not be okay, because that's what we talked about the other day. Okay, so if you had this is not a polynomial because you can't have a variable in the denominator. Okay, and I do want to remind you of that because you could see that on tonight's homework. Okay, and that is something that we talked about previously. They can be next to it like this, so this would be the same thing as negative 3m to the 7th divided by 4, and that's why this one's okay. Did that not answer the question? Is there another way that you're thinking of it? Yes, so negative 3m to the 7th over 4 is the same thing as this. Yep, those are equivalent. All right, and then the last one is 6ab squared divided by c. So like I said earlier, this does not specify that it has to be in one variable. So the number of variables here is not the problem. Okay, the problem is you have a variable where it can't be, which is where? In the denominator. Okay, so not a polynomial because you can't have, and if you want to say, instead of like variable, if you want to say what variable's in there, so not a polynomial because you can't have c in the denominator, that would be fine as well. And if you just had this, it would be a polynomial. In fact, it would be a monomial because it's one term, 6 times a times b squared. All right, so remember your situations from yesterday. You can't have negative exponents, okay, which means you can't have a variable in the denominator, okay, and you can't have any of those roots, which are fractional exponents. Okay, so in examples 2 and 3, you are going to add or subtract. You're going to write your answer in standard form. So when you're adding in part A, all you have to do is add your like terms together. Like terms are going to be the same variable to the same power. So because we're writing this in standard form, let's start with the highest power. So I want you to find the highest powers. If you want to use an underlining strategy, that's probably something that you guys did in Algebra 1, where you underline them the same. That we guys did it before. Okay, so the highest exponent is x cubed. So I have 2x cubed and x cubed, so I might underline those both once. Once you've determined their like terms, you add the numbers in front. What number's in front here? 1. So 1 plus 2 is 3. So this would be 3x cubed. Okay, and then with the x squared, there's only one x squared, 5x squared, so I'm going to put that next. Okay, then I'm going to look for my x's. So here I have negative x and 7x. I want you guys to write down what that's going to be, and then I want you to do the constant. Okay, even if you're unsure, just jot something down so I can look at it, okay? Okay, so let's see what we came up with here. So negative x and 7x, what do we get for that? 6x, yeah? Okay, and then your numbers, do you guys do like a squiggle or a triangle? What did you decide? Yeah. So you guys can choose whatever works for you. I know that this is a strategy you've done before. I like that, just underlining them the same. Okay, and then if you want to do one at a time, or like some people will cross them out as they go, that's okay too. When you have minus, I find it's really helpful, especially when this is not in standard form. I do not like that, but it is something we have to deal with. So what I like to do is I like to distribute the negative, because when you do that, then you can underline your like terms and combine them like we did in part A. So when you distribute the negative, it means you're taking this minus sign, okay, and you're making this negative x squared, because a negative times a positive is a negative. Negative times 6 is negative 6. Negative times negative x is positive x. Okay, and then we're ready to find our like terms again. So here I have negative 2x and negative x squared. Remember here you're adding. So it's a negative 2 and a negative 1, which is going to give us negative 3. So it's negative 3x squared. Okay, go ahead and finish that, and then I want you to do part C. All right, so we have negative 3x squared. Okay, and then when you were combining the next one, you only had x, right? Just this plus x. Okay, and then you had a positive 3 and a negative 6. So what did that turn into? Negative 3. Okay, nice. All right, and then I asked you to do this one as well. So negative y squared plus 2y plus 3. Again, start by looking for your largest exponent. The largest exponent is going to be 5y cubed. If there's no other like term, that's going to stay the same. And then after that, we can look for this y squared. The y squared doesn't change. The only thing that changes is that value in front. So it's negative 3y squared. Okay, and then I'm going to look for the y. The only y I have is 2y. And then I have negative 1 and positive 3, so we got plus 2. Okay, thumbs up if we got that correct. All right, then we are ready to multiply. When you multiply, you are going to write your answer in standard form. The only time you are exempt from that is if you have more than 2 variables. So if there are more than 2 variables, there's no standard form. And you'll only have one of those in this one, just so you know. If there's more than 2, bless you. Okay, there's no standard form, which means you don't have to worry about putting those in a certain order. Okay, we are going to end up multiplying some different variables today. When you are multiplying variables, you are going to want to put them in alphabetical order. Okay, and I'll go through that with you. All right, so when you're multiplying, here we're going to distribute. When you are multiplying y squared times y squared, remember that the rule is when you're multiplying the same variable, you add their exponents. So this becomes 4 because of addition, not as multiplication. So I would like you to write down this property. Okay, that is why it is y to the 4th, not because of multiplication. So when I do this, I multiply the values in front. If there's no value in front, it's just going to say 4. So this is 4 times 1, which is 4. Y squared times y squared, we said was y to the 4th. Okay, and then I want you to try to do the second one, 4y squared times 3. And then I want you to write that down here. And then I want you to do part B. Okay, just do your best. It's okay if you make a mistake. All right, so we should have got 12y squared. How do we do? Okay, now we got to be careful with B. Okay, there is a reason I had to try it, because a lot of people make this same mistake. Okay, they try to square both of those. You should not have a binomial. If you have a binomial, you just forgot this one thing. Okay, so we're going to correct it. So when you have a binomial squared, remember this means 3r minus 7 times 3r minus 7. So you should not have 9r squared plus 49. Because what about multiplying the inside and the outside? So when you have this, you do have to FOIL. Okay, so just be careful. It's okay if you made that mistake. That is a common mistake. We just want to correct it so we don't make that in the future, okay? So 3r minus 7 squared is a binomial. So we're going to write it out. We're going to FOIL. 3r times 3r is 9r squared. In the middle, we have 21r. In the outside, we have 21r, both negative. And then negative times a negative is a positive. So your final answer for this is 9r squared minus 42r plus 49. Okay, so we are multiplying, we are expanding these. Because we are writing these in standard form, okay, you can distribute this right away. You can multiply everything by a and then everything by -3. That's fine. I like to write it in standard form first. So if I want to write this in standard form, I might do this first, because then when I distribute, it's already going to be that way. Okay, I'll show you both ways how to do it, because I did it a different way earlier. If I distribute a to everything, if I multiply everything by a, think about what happens here. What's a times a squared? A cubed. A times -5a is -5a squared. A times 2, 2a. Okay, and then once I distribute the -3 to everything, I'm going to strategically line these up so that I can add my like terms straight down. So if I do -3 times a squared, -3a squared is going to go underneath my other a squared. -3 times -5 is positive 15a. So I'm going to put that underneath. And then -3 times -2 is -6. Okay, that just makes it a little nicer, so when you are ready to add those like terms, you can add them straight down. Okay, if you want to write them all in one big line and underline, you can. But I think that this is helpful. Okay? All right, so once you add those together, you're going to get a to the third negative 8a squared plus 17a minus 6. This is in standard form because standard form starts with the largest exponent and then goes in decreasing order. So a to the third, a to the second, a, and then negative 6. Okay, if you didn't put it in standard form, you could still find these values. Okay, you would have had 2a, negative 5a squared, and a cubed. And then when you distributed the negative 3, negative 6, 15a, negative 3a squared, would just be in that backwards order. And then you would put it in standard form. Okay, so you can decide whichever way you like better. All right? Okay, we're going to tackle part B together because we have not 1, not 2, not 3, but 4 variables. So let's talk some strategies. You are going to pick 2 binomials to FOIL. Now, depending on your situation, you might be able to pick any 2 that you want. For this situation, we are going to choose the values with the same variables if you can. So when you're picking which ones to FOIL, do the ones with the same variables first. Okay, you don't have to, it just makes it a little bit easier. And in some cases, you might have all of the same variables and then it's not going to matter. Okay? So I want you to go ahead and I want you to FOIL these. When you do this, you are going to make sure that you put the variables in alpha order. So alphabetical order. Okay, put in alpha order. Okay, so I want you to go ahead and try to FOIL those. All right, so then when you multiply 4a times a, so we're going to FOIL, right? So 4a times a is going to be 4a squared. And then a times b is going to be here. And then on the outside, we have negative 8ab. And then b times negative 2b is negative 2b squared. Okay, you do have like terms in here. So this is 4a squared. 1ab minus 8ab is negative 7ab. Okay, and then we are going to distribute. Okay, do you guys think that you could distribute these without me? Are you scared? Okay. If you need just a hint, I want you to first multiply everything by 3c. We're going to write that down first. I was going to say, I'll be done in 10 minutes. Okay. Okay, so let's see how we did. So 3c times the 4a squared. Okay, I'm just gonna tell you what I'm thinking about as I'm doing this. because this can be overwhelming. So what I do is I multiply the 3 times the 4. So I'm saying to myself, 3 times 4, that's going to be 12. A squared times C is A squared C. Okay, and then I'm moving along. And I am keeping my finger here, which seems really small, but I do think it helps eliminate some of those smaller mistakes. So 3 times negative 7 is negative 21. AB times C is ABC. Easy as 1, 2, 3. Okay, so is that going to make you guys more confident to do that next one? Think you can do that one? Okay, so negative 2b squared times 3c. Okay, so in your head, yep, negative 6. B squared c. Nice job. Okay, and now we're going to distribute negative d to everything. I'm going to actually use the same color because we're not going to have any like terms this time. If it's a negative, all that does is change the sign. So for 4a squared, it's going to become negative 4a squared d. When you have a negative times a negative, we know that becomes a plus. Okay, so we have our plus 7. AB times D is ABD. And then for our last one, negative times a negative is a positive B squared D. Okay, so if you look at these, some of these are very close. This is A2C, this is A2D. Okay, so, but none of them are the exact same, so there are no like terms. Okay, you aren't going to have a ton of these. Okay, but it is nice to get thinking about those other variables. Okay. All right, I'm going to show you another strategy for part E and for part F. So sometimes people make small mistakes just because your eyes are looking back and forth. Okay, you don't have to do it like this. You can choose. But when you distribute the negative 2c, you are multiplying 2c to 5c to the 5th plus 2c squared minus 8c plus 4. And then when you distribute the negative 3, again, you're distributing it to this. So sometimes it can be helpful to write this out and then line up your like terms. Because then you're only going back and forth here. You're only going back and forth here. Okay, so I want you to give this a try. So multiply everything by 2c. How about I do the first one with you? So 2c times 5c to the 5th. 2 times 5 is 10. C times c to the 5th is c to the 6th. Okay, and then I want you guys to try to finish that, and then we'll check in with each other. All right, so check yours with me. Okay, so the next one should be 4c to the 3rd. Then you have negative 16c squared, and then 8c. Okay, thumbs up if we got all those correct for the first one. All right, great. Okay, and then the next row, when I do this, I'm going to be strategic about lining them up. So this would be c to the 5th. There is no c to the 5th, so I'm just going to put it there. Really, I should have put it here. But negative 3 times 2 is going to be negative 6c squared. So I'm going to line that up there. a negative times a negative is 24C, okay, and then negative 12. So when you're adding some of these together, some of them are not going to have a partner. So 10C to the 6 stays, okay. The next one is the C to the 5th. And then, like I said, I really would have wanted to put that in the middle so I'd remember. And then 4C cubed. And then when they have the same, that's when they're like terms. So negative 16 minus 6. When you are combining negatives, you are just adding these together. So this is going to be negative 22. 8 and 24, what do we get? 32, good. And then the negative 12. And again, this is in standard form because you're starting with the highest exponent and then you're working your way down. Okay, that was part E. Okay, for part F, you have a trinomial times a trinomial. So if you want to use the same strategy, notice what I did is I took the binomial and multiplied it by the same polynomial here. Okay, if you want to use that strategy with F, we would take y squared, negative 7y, and 5, and we would multiply it by this trinomial. You can also distribute like we did earlier and combine your like terms. Okay, you can make a long list of terms and combine them. All of that is fine. Okay, but I'm going to give you a couple minutes now to do part F. If you are done and waiting for me to check it, you can feel free to get a Chromebook and start your homework on the calendar. I'll put it on the board. All right, and then when you're ready to check yours with mine, you can quietly check it as you start your assignment. Will you just double check your final answer? You check your final answer. Okay, and then if you have done this same process and you did make a mistake, this is going to make it easy to find. Okay, and don't forget your last step of combining your like terms. Normally, if people make a mistake, it's something small that's a computational error because you're going back and forth between adding, subtracting, and multiplying. So we just want to make sure we're double checking some of those small things here. Okay, and once you have verified that your part F is the same as mine, okay, I put your homework on the board.